For more videos like this for Discrete 1, you can take a look at Sarai Studies. The link is in the description box below. We're told to show or prove that this compound proposition is equivalent to this compound proposition. First thing you want to do is identify what is your most complicated looking compound proposition. That's this one right here. Now my goal is to get this side to look like this side using this table. So I'm going to go ahead and write this down, not P and P or Q, and then I'm going to ask myself, what is that equivalent to? Well, here I see a proposition, an and another compound proposition with an or. So I'm going to look for something similar in my table. Well, here I see a proposition, here I see an and, here I see another proposition, here's an or. This is the exact same format that we have right here. So what does it say that this is equivalent to? Well, it says that this is equivalent to P and, so the ands go inside. Whatever Q was goes here. Whatever R was goes here. And then the sign that was actually in the inside goes outside. So if we follow that format, it's going to be 2 parentheses with an or in the middle. Whatever was on the outside is going to be the first thing on the inside in both parentheses. In this case, that's going to be not P, not P. Then the symbol that was on the outside goes on the inside. So the symbol that was on the outside goes on the inside. And then what was inside the compound proposition, the first thing goes in the first parenthesis and the last thing goes in the last parenthesis. So first thing goes in the first parenthesis, last thing goes in the second parenthesis. So what law did we use? This is the distributive law. So we write distributive law. Now no, this is really annoying. You having to figure out what goes where. You can just intuitively understand, you see something, a symbol, and then a compound proposition. No matter what these symbols are, whether they're and or, you're going to have 2 parentheses. The symbol that was on the outside now goes on the inside. The symbol that was on the inside now goes on the outside. The first thing that you see is going to go as a first thing in each of the parentheses. Then whatever's left, you just put in the same order that they are in the parentheses. But the problem is this still does not look like this, so we have to keep going. What is this equivalent to? Well, look inside the parentheses. Here we have not P and P. So intuitively, without even looking at this, if you have something that's true and the opposite of that, so false, and you know an and is only going to give you true if this and this are true, otherwise it's going to give you false. Well, both of these are not true, so it's going to give you false. So you know that this is always going to give you false. Even if you do the opposite, if you assume that P is false, you have an and then, well, this is not P, so it's going to be the opposite of false, that's true. Again, and is only going to give you true if this and this are true. That's not the case. It's going to give you false. So either way, this is always going to give you false. This is called the negation laws. That's right here. When you have P and the opposite of P is always going to give you false. So this here becomes false, and then we drop everything else, or not P and Q. What law did we use again? Negation. So you have to write that, negation law. This still does not look like this side. So what do we do? Well, there's this interesting law here that says if you have false or something, so false or something, it's always just going to be equal to that something. So this is going to be equivalent to that something, which is just not P and Q. What law did we use? The identity law. So we write that. And finally, we have the other side. So we managed to go from here to here using known equivalences. So we proved that this compound proposition is equivalent to this at the end of the day. So we write a little square to say that we're done. Now there's one more thing I want to clarify about the identity law, which is what we use to go from here to here. The identity law says that if you have something or false, it's going to give you that something. But don't get confused and think, oh, this is just when I have an atomic proposition, when I have something like R, Q, S. No, this is a placeholder for whatever is next to or false. In this case, this P is a placeholder for this compound proposition. That's what P is here. So something or false is going to give you that something. Something or false is going to give you that something. And that's it for this video. I'll see you in the next.